Hi there. Welcome to our new unit. This is Unit 8, where we are going to be really focusing on solutions. Solutions examples might be salt water, sugar water, Gatorade, tea, coffee, things like that. And Today we're going to focus on what makes a solution, which is going to begin with a discussion of water and mixtures. Here we go. First up, again, this unit is all about solutions. Mixtures can be a solution. A solution is a homogeneous mixture made up of two or more substances that are uniformly dispersed throughout a single phase. In other words, a mixture that is totally mixed. It is completely the same throughout, and you cannot see different parts. Tap water is an example of a mixture. You might not think of it like that, but tap water actually has minerals dissolved in it and it is not pure. So water is an example of a solution, a homogeneous mixture. Most solutions we look at will be water-based, so we're going to take a deep dive into water. All right, so water is a polar molecule. That means that each water molecule has a partial negative charge on one end and a partial positive on the other. The negative end is on the oxygen side of the water molecule, and the positive end is on the hydrogen side. I like to call these Mickey's ears. The polarity of each water molecule allows it to attract other polar particles, such as other water molecules, or other polar molecules, or even ions. So water is essentially very sticky. It has the ability to attract and stick to other molecules as long as those other molecules are polar or have a charge because they're an ion. When two or more water molecules are near each other, they are going to attract. And that's because of the difference in charge, that's that stickiness. This attraction between molecules is called hydrogen bonding. This is a very particular type of attraction between molecules that have hydrogen and oxygen, nitrogen, or fluorine. So water qualifies as having hydrogen bonding. All right, again, the weak positive hydrogen of one water molecule is going to be attracted to the weak negative oxygen of another water molecule. They're going to stick together, and as this group of water molecules grows and grows and grows, eventually you would get water droplets. So really, this water droplet that I'm pointing at here is just millions and billions of water molecules that are all stuck together because water is polar. Again, after a lot of hydrogen bonds form, you have a weak force holding all the water molecules together. That's called hydrogen bonding. Okay, because of hydrogen bonding and polarity, water does have some unique properties. So we'll go through these one by one. First up, a high boiling point. Water has an unusually high boiling point compared to other liquids. Other liquids vaporize and boil easier at a lower temperature because they don't have such strong bonds and attractions. But water has hydrogen bonding. It's a high boiling point compared to other liquids. Water has a high surface tension. High surface tension means that because those water molecules stick together, they actually form beads of water. So this water right here, the water molecules along the surface are held together very tightly, almost like they form a little border of water molecules along the edge. So it's called surface tension or cohesion. Cohesion, just like if you're talking about a cohesive group of people, a cohesive group of water molecules sticks together. And so that is the high surface tension. Now, a little side note here that the surface tension can be reduced with what's called a surfactant. Soap is a great example of this. It actually disrupts the hydrogen bonding. All right, and finally we have adhesion. Water molecules are able to attract to glass because glass molecules are polar. Okay, so adhesion means sticking to other things. Unique properties of water continued. Capillary action is one. Capillary action is a very particular ability that water has to be drawn up through a very thin glass tube with almost no effort. That's because of the attraction between the water and the glass molecules and the fact that the water is attracted to itself. So as the water begins drawing up that tube, it pulls up the water below it, and that pulls up the water below it, and so it can actually continue up that tube. The smaller the tube is, the farther the water is going to go. All right, moving on to page 4 of your notes, we're going to review matter for a little while. So matter in this table, as you can see, can be divided into pure substances, which we have covered, and mixtures, which we're covering in more detail now. Beginning with a quick review of pure substances. Elements are an example of a pure substance. Quick review, they are one of the 118 substances found on the periodic table. They cannot be separated by any sort of normal change, and they are represented by a single symbol on the periodic table. So if you think about the periodic table, what are some elements you think of? Go ahead and list those as some examples in your notes. Literally any element off the periodic table. Some examples that you might use are gold, which is Au, hydrogen, H, or potassium is K. Another example of a pure substance is compounds. This one is sometimes a little bit confusing because a compound is made up of 2 or more elements, but the atoms are bonded together, and they're bonded together in a very particular ratio so that every single molecule side by side is the same as the one next to it. So because every molecule is the same, compounds are pure. The atoms, again, are bonded together. They can only be separated by chemical changes, and they are represented by a chemical formula. That chemical formula includes 2 or more elements from the periodic table and sometimes some subscripts. So think of some examples of compounds and jot them down. If you need some ideas, H2O, water, CO2, carbon dioxide that you're breathing out right now, and NaCl, which is salt. Those are all examples of pure substances called compounds. All right, finally, let's go to the other side. Let's go to mixtures. Mixtures are when you have 2 or more pure substances that can be separated by physical changes. So they are mixed up, but you could separate them. So there are 2 types of mixtures. They are heterogeneous mixtures and homogeneous mixtures. So heterogeneous mixtures, 2 types, would include what's called a suspension and a colloid. We'll talk about what that is in just a second. And then finally, homogeneous mixtures are also known as solutions. That is going to be our main focus in this unit after we get through the basics here. So first up, let's talk about heterogeneous mixtures, which again are 2 or more pure substances mixed unevenly. And you can even see the different components. So great examples, pizza, dirt, muddy water, all of these are examples of heterogeneous mixtures because you can see that there's more than one thing in it. Now, the 2 specific types of heterogeneous mixtures that we're going to look at here today, because they're sometimes confused with solutions, are suspensions and colloids. The suspensions are water-based mixtures, but they do not mix evenly, and there are very large particles, okay? So the particles can be suspended when it's in motion, but they will eventually settle to the bottom if it's not in motion. And they can be separated using a filter. So an example of a suspension that you can imagine is sand in water. So imagine you go to the beach and you have a cup and you just scoop up some sandy water. Well, what's going to happen pretty quickly is that sand is going to fall to the bottom. That is how you know this is a suspension. If the particles are so big that gravity takes over and pulls them down to the bottom, that is going to be a suspension. Colloids are also a heterogeneous mixture. They have medium particles, okay? They're not heavy enough to settle, but they do float around in solution. Sorry, said the wrong word. They do float around in the mixture, but again, they're not heavy enough to settle, but they can be pulled out if you use a little force, such as spinning. We're going to talk about the centrifuging in a minute. Colloids are also sometimes kind of foggy looking. So think about smoke or fog or jello. If they're a little bit foggy, they might be a colloid. These are not solutions, which is what we're going to talk about in this unit. All right, finally, a homogeneous mixture. This is 2 or more pure substances mixed evenly. It's the same throughout. When you look at it, you cannot see the different parts. These are also called solutions. So homogeneous mixture and solution, those are synonyms. They mean the same thing. One example of a solution is called an alloy. It's the type of solution made by melting two or more elements together, and at least one of them is a metal. So if you think about metals that have a name but they're not on the periodic table, it's usually an alloy. So I like to think about brass. You know, like a brass instrument, like a trumpet or a French horn. Brass is not on the periodic table. That means that brass is an alloy. It is a mixture of metals. Brass is copper and tin, I believe, and they are, no, sorry, copper and zinc, and they are mixed together and melted down and then resolidified in a certain shape. Steel is another example. All right, so these are all examples of solutions. Solutions can be liquid-based, like sugar water. They can be solid, like steel or brass that we talked about. There's another liquid, salt water. There's another liquid, pancake syrup, which is basically sugar water. Natural gas would be an example, okay? So natural gas is going to have a couple different carbon-based compounds in it that will all burn. The air around you is another example. The air that you're breathing right now has oxygen, nitrogen, carbon dioxide, pollutants, and they're all just evenly mixed up. That makes air a solution. Okay. Our last topic for this section of the notes is to talk about how can mixtures be separated. Okay, watch this little picture here. We've got a mixture of iron, filings, sand, and water. First, we could filter it. That separates the solids. Then how do you get the iron and the sand separated? You use this magnet here. Okay, I'll let you watch that one more time. The water pours through and the solids stay. That's filtering. Then we can use magnetic separation to separate out the iron. All right. So in class we did an activity, but I'm going to skip that slide for now. So remember that mixtures can only be physically separated by physical change. The atoms are not rearranged into new substances. So in this example here, we had iron, water, and sand all mixed together. In the end, we still have water ends up in the beaker, sand ends up in this pan, and the iron ends up stuck to the metal. All of the chemicals still exist. They've just been separated. So a couple different ways that we can separate mixtures. First step, magnetic separation, is what you saw with the magnet pulling the iron out of the sand. You can separate particles based on their magnetic properties. If one is magnetic and one is not, you can use a magnet to separate them. Sieving is our next method of separation. Sieving can separate solid particles based on different sizes if they pass through a mesh or a net. So the example that I like to think of is old gold prospectors, you know, back when there was the California gold rush, they would pan for gold. So they would pick up a scoop of like sediment from the bottom of a river and they would pass it through a gold pan. And that would allow the mud and water to fall through and the gold would stay in the pan. So that's a process called sieving. Next up, we have evaporation. This is a very common one. You can separate a dissolved solute from the solution by evaporating the liquid away. Usually that's going to be the water that you evaporate away. So if this was a beaker of salt water, if you heated it up, the water would evaporate away and the salt would be left behind. It's still salt and water, but they were separated from each other. That's evaporation separation. Next, we have filtration. This is separating a solid from a liquid by using something like paper that catches the solids and only allows the liquids through. So if you have sandy water, you could pass it through a filter. Just think of like a coffee filter. You know, it's a paper that allows the liquid to go through, but the solids are going to be trapped. That's filtration. Next up, decanting. If you imagine a mixture where something has settled down to the bottom, and you could slowly pour off the liquid and the sediment remains behind, that's called decanting, all right? So this is separating mixtures by pouring the liquid on top out while keeping the solids undisturbed at the bottom. Next up, centrifugation. This picture here is necessary to understand it. If you put mixtures in these little vials here and spin them, the heavy stuff is going to fall to the bottom. So separating liquids of different densities or solids from liquids by using a centrifugal force. That's the spinning force in this machine. So they actually use this to separate blood samples into red blood cells and the rest of the blood. I think it's the plasma, it actually separates it into 2 layers. So blood on its own will stay mixed, but it is a colloid, and so if you give it the force of a centrifuge, it will separate into layers. Next, we have distillation, separating mixtures based on phase changes of each component. So in this example, if you have a mixture of, let's say, 2 liquids, so it might be like rubbing alcohol and water. If you heat it just a little bit and it passes through this machine, water can vaporize out and the distillate, which is the other chemical, can end up here in this flask. Chromatography is if you separate mixtures through a process using a paper to separate it. It's called a stationary and mobile phase. Essentially, if you put a little ink dot here and then dip it in the water, and the ink dot travels up and separates into different colors, those are the different dyes in the ink. That is a method of separation called chromatography. And finally, crystallization. This is separating solids from liquids by forming solid crystals in the solution. As you can see with the thermometers here, this is sometimes done by heating and cooling a solution. So if you heat it up and it's dissolved, but then you cool it back down and it recrystallizes, that would be called crystallization. This is what we actually use to make like rock candy, and we're actually going to do that as an experiment as an extra credit assignment this quarter. All right, y'all, that is our last slide. Thank you for following along for topic 1 here. If you need any more information, please feel free to check the HyperDoc or the Wakelet that we have set up for this topic. And if you have any further questions, just let us know. We're happy to help. Thanks for watching. Bye.